ISO 8601 Data Elements and Interchange Formats. Information interchange. Representation of dates and times is an international standard covering the exchange of date and time-related data. It was issued by the International Organization for Standardization and was first published in 1988. The purpose of this standard is to provide an unambiguous and well-defined method of representing dates and times, so as to avoid misinterpretation of numeric representations of dates and times, particularly when data are transferred between countries with different conventions for writing numeric dates and times. In general, ISO 8601 applies to representations and formats of dates in the Gregorian calendar, times based on the 24-hour timekeeping system, time intervals and combinations thereof. The standard does not assign any specific meaning to elements of the date time to be represented. The meaning will depend on the context of its use. In addition, dates and times to be represented cannot include words with no specified numerical meaning in the standard that do not use characters. In representations for interchange, dates and times are arranged so the largest temporal term is placed to the left and each successively smaller term is placed to the right of the previous term. Representations must be written in a combination of Arabic numerals and certain characters that are given specific meanings within the standard. The implication is that some commonplace ways of writing parts of dates, such as January or Thursday, are not allowed in interchange representations. History. The first edition of the ISO 8601 standard was published as ISO 8601 to 1988 in 1988. It unified and replaced a number of older ISO standards on various aspects of date and time notation. ISO 2014, ISO 2015, ISO 2711, ISO 3307, and ISO 4031. It has been superseded by a second edition, ISO 8601 to 2000 in 2000, and by the current third edition, ISO 8601 to 2004, published on 1 December 2004. ISO 8601 was prepared by, and is under the direct responsibility of, ISO Technical Committee TC 154. ISO 2014, though superseded, is the standard that originally introduced the all-numeric date notation in most to least significant order. The ISO week numbering system was introduced in ISO 2015, and the identification of days by ordinal dates was originally defined in ISO 2711. General principles. Date and time values are ordered from the largest to smallest unit of time: year, month, day, hour, minute, second, and fraction of second. The lexicographical order of the representation thus corresponds to chronological order, except for date representations involving negative years. This allows dates to be naturally sorted by, for example, file systems. Each date and time value has a fixed number of digits that must be padded with leading zeros. Representations can be done in one of two formats: a basic format with a minimal number of separators, or an extended format with separators added, to enhance human readability. The standard notes that the basic format should be avoided in plain text. The separator used between date values is the hyphen, while the colon is used as the separator between time values. For example, the 6th day of the first month of the year 2009 may be written as the 6th of January 2009 in the extended format as simply as 20,090,106 in the basic format, without ambiguity. For reduced accuracy, any number of values may be dropped from any of the date and time representations, but in the order from the least to the most significant. For example, 2004-05 is a valid ISO 8601 date, which indicates May 2004. This format will never represent the 5th day of an unspecified month in 2004, nor will it represent a time span extending from 2004 into 2005. If necessary for a particular application, the standard supports the addition of a decimal fraction to the smallest time value in the representation. Dates. The standard uses the Gregorian calendar, which serves as an international standard for civil use. ISO 8601 fixes a reference calendar date to the Gregorian calendar of the 20th of May 1875 as the date the Convention du Meter was signed in Paris. However, ISO calendar dates before the Convention are still compatible with the Gregorian calendar all the way back to the official introduction of the Gregorian calendar on the 15th of October 1582. Earlier dates, in the proleptic Gregorian calendar, may be used by mutual agreement of the partners exchanging information. The standard states that every date must be consecutive, so usage of the Julian calendar would be contrary to the standard. Years ISO 8601 prescribes, as a minimum, a 4-digit year to avoid the year 2000 problem. It therefore represents years from 0000 to 9999, year 000 being equal to 01 BCE and all others CE. However, years prior to 1583 are not automatically allowed by the standard. Instead, values in the range through shall only be used by mutual agreement of the partners in information interchange. To represent years before 0000 or after 9999, the standard also permits the expansion of the year representation, but only by prior agreement between the sender and the receiver. An expanded year representation must have an agreed-upon number of extra year digits beyond the 4-digit minimum, and it must be prefixed with a plus or minus sign instead of the more common AD, BC notation. By convention, 01 BC is labeled plus 0002 BC is labeled 0001, and so on. Calendar dates. Calendar date representations are in the form shown in the box to the right. Indicates a 4-digit year, 000 through 9999. Indicates a 2-digit month of the year, 01 through 12. Indicates a 2-digit day of that month, 01 through 31. For example, the 5th of April 1981 may be represented as either the 5th of April 1981 in the extended format or 19,810,405 in the basic format. The standard also allows for calendar dates to be written with reduced accuracy. For example, one may write 1981-04 to mean 1981 April. The 2000 version allowed writing 04-05 to mean April 5th, but the 2004 version does not allow omitting the year when a month is present. One may simply write 1981 to refer to that year, or 19 to refer to the century from 1900 to 1999 inclusive. Although the standard allows both the YYYYMMDD and YYYYMMDD formats for complete calendar date representations. If the day is omitted, then only the YYYYMM format is allowed. By disallowing dates of the form YYYYMM, the standard avoids confusion with the truncated representation YYMMDD. Week dates. Week date representations are in the format as shown in the box to the right. Indicates the ISO week numbering year, which is slightly different from the traditional Gregorian calendar year. Is the week number prefixed by the letter W, from W01 through W53. Is the weekday number from 1 through 7, beginning with Monday and ending with Sunday. There are several mutually equivalent incompatible descriptions of week 01, the week with the year's first Thursday in it, the week with the 4th of January in it, the first week with the majority of its days in the starting year, and the week starting with the Monday in the period the 29th of December, the 4th of January. As a consequence, if the 1st of January is on a Monday, Tuesday, Wednesday or Thursday, it is in week 01. If the 1st of January is on a Friday, Saturday or Sunday, it is in week 52 or 53 of the previous year. The 28th of December is always in the last week of its year. The week number can be described by counting the Thursdays. Week 12 contains the 12th Thursday of the year. The ISO week numbering year starts at the first day of week 01 and ends at the Sunday before the new ISO year. It consists of 52 or 53 full weeks. The ISO week numbering year number deviates from the number of the traditional Gregorian calendar year on a Friday, Saturday, and Sunday, or a Saturday and Sunday, or just a Sunday, at the start of the traditional Gregorian calendar year and a Monday, Tuesday and Wednesday, or a Monday and Tuesday, or just a Monday, at the end of the traditional Gregorian calendar year. For Thursdays, the ISO week numbering year number is always equal to the traditional Gregorian calendar year number. Examples: Monday the 29th of December 2008 is written 2009 W011. Sunday the 3rd of January 2010 is written 2009 W53-7. Ordinal dates. An ordinal date is a simple form for occasions when the arbitrary nature of week and month definitions are more of an impediment than an aid. For instance, when comparing dates from different calendars, as represented above, indicates a year, is the day of that year, from 001 through 365. For example, the 5th of April 1981 is also 1981-2095. This format is used with simple hardware systems that have a need for a date system, but where including full calendar calculation software may be a significant nuisance. This system is sometimes referred to as Julian date, but this can cause confusion with the astronomical Julian day, a sequential count of the number of days since day 0 beginning the 1st of January 4713 BC Greenwich noon. Julian proleptic calendar times. ISO 8601 uses the 24-hour clock system. The basic format is and the extended format is : refers to a zero-padded hour between 00 and 24. Refers to a zero-padded minute between 00 and 59. Refers to a zero-padded second between 00 and 60. So a time might appear as either 134,730 in the basic format or 13 hours 47 minutes and 30 seconds in the extended format. Either the seconds or the minutes and seconds may be omitted from the basic or extended time formats for greater brevity but decreased accuracy, and of the resulting reduced accuracy time formats. Midnight is a special case and may be referred to as either 0000 or 2400. The notation 0000 is used at the beginning of a calendar day and is the more frequently used. At the end of a day use 2400. The 5th of April 2007 T2400 is the same instant as the 6th of April 2007 T000. Decimal fractions may be added to any of the 3 time elements. However, a fraction may only be added to the lowest order time element in the representation. A decimal mark, either a comma or a dot, is used as a separator between the time element and its fraction. To denote 14 hours, 30 and 1/2 minutes do not include a seconds figure. Represent it as 14:30, 5, 14:30, 5, 14 minutes 30 seconds and 5 milliseconds, or 1430.5. There is no limit on the number of decimal places for the decimal fraction. However, the number of decimal places needs to be agreed to by the communicating parties. Time zone designators. Time zones in ISO 8601 are represented as local time, as UTC, or as an offset from UTC. If no UTC relation information is given with a time representation, the time is assumed to be in local time. While it may be safe to assume a local time when communicating in the same time zone, it is ambiguous when used in communicating across different time zones. Even within a single geographic time zone, similar local times will be ambiguous if the region observes daylight saving time. It is usually preferable to indicate a time zone using the standards notation. UTC. If the time is in UTC, add a Z directly after the time without a space. Z is the zone designator for the 0 UTC offset. 9:30 UTC is therefore represented as 9:30 Z or 0930 Z. 14 hours 45 minutes and 15 seconds UTC would be 14 hours 45 minutes and 15 seconds Z or 144515 Z. UTC time is also known as Zulu time, since Zulu is the NATO phonetic alphabet word for Z. Time offsets from UTC. The offset from UTC is appended to the time in the same way that Z was above, in the form plus or minus, or plus or minus. So if the time being described is 1 hour ahead of UTC, the zone designator would be +1 o'clock, +0100, or simply +01. To represent a time behind UTC, the offset is negative. For example, the time in New York in winter is UTC -5 o'clock. For other time offsets, see list of UTC time offsets. To represent a negative offset, ISO 8601 specifies using either a hyphen minus or a minus sign character. If the interchange character set is limited and does not have a minus sign character, then the hyphen minus should be used. ASCII does not have a minus sign, so its hyphen minus character would be used. If the character set has a minus sign, then that character should be used. Unicode has a minus sign, and its character code is U+2212. The HTML character entity invocation is an amp minus. Using the minus sign conflicts with similar standards, so ISO 8601 implementations will probably accept both hyphen minus and minus sign characters. The following times all refer to the same moment: 1830 Z, 2230 +04, 1130 -0700, and 1500 -330. Nautical time zone letters are not used with the exception of Z. To calculate UTC time, one has to subtract the offset from the local time, e.g. for 1500 -330, the 1500 to get 1830 UTC, an offset of 0. In addition to having the special representation, Z can also be stated numerically as +000, +000, or +00. However, it is not permitted to state it numerically with a negative sign, as -000, -000, or -00. The section dictating sign usage states that a plus sign must be used for a positive 0 value, and a minus sign for a negative value. Contrary to this rule, RFC 3339, which is otherwise a profile of ISO 8601, permits the use of OO, with the same denotation as +OO but a differing connotation. ISO 8601 permits the hyphen to be used as the minus character when the character set is limited. In contrast, RFC 3339 explicitly requires the hyphen symbol to represent negative offsets and does not allow for use of the minus symbol. Combined date and time representations. A single point in time can be represented by concatenating a complete date expression, the letter T as a delimiter and a valid time expression. For example, the 5th of April 2007 T1430. If a time zone designator is required, it follows the combined date and time. For example, the 5th of April 2007 T1430Z, or the 5th of April 2007 T1230 to 2 o'clock. Either basic or extended formats may be used, but both date and time must use the same format. The date expression may be calendar, week, or ordinal, and must use a complete representation. The time may be represented using a specified reduced accuracy format. It is permitted to omit the T character by mutual agreement. Durations. Durations are a component of time intervals and define the amount of intervening time in a time interval. They should only be used as part of a time interval as prescribed by the standard. Time intervals are discussed in the next section. Durations are represented by the format PYMDTHMSPW as shown to the right. In these representations, the is replaced by the value for each of the date and time elements that follow the leading zeros are not required, but the maximum number of digits for each element should be agreed to by the communicating parties. The capital letters P, Y, M, W, D, T, H, M, and S are designators for each of the date and time elements and are not replaced. P is the duration designator placed at the start of the duration representation. Y is the year designator that follows the value for the number of years. M is the month designator that follows the value for the number of months. W is the week designator that follows the value for the number of weeks. D is the day designator that follows the value for the number of days. T is the time designator that precedes the time components of the representation. H is the hour designator that follows the value for the number of hours. M is the minute designator that follows the value for the number of minutes. S is the second designator that follows the value for the number of seconds. For example, P3Y6M4DT1-H30M5S represents a duration of 3 years, 6 months, 4 days, 12 hours, 30 minutes, and 5 seconds. Date and time elements including the designator may be omitted if the value is 0, and lower order elements may also be omitted for reduced precision. For example, P23DT23H and P4Y are both acceptable duration representations. To resolve ambiguity, P1M is a 1-month duration and PT1M is a 1-minute duration. The smallest value used may also have a decimal fraction, as in P0, 5Y, to indicate half a year. This decimal fraction may be specified with either a comma or a full stop, as in P0, 5Y, or P0, 5Y. The standard does not prohibit date and time values in a duration representation from exceeding their carry-over points, except as noted below. Thus, PT36H could be used as well as P1DT12H for representing the same duration, but keep in mind that PT36H is not the same as P1DT12H when switching from it to daylight saving time. Alternatively, a format for duration based on combined date and time representations may be used by agreement between the communicating parties, either in the basic format PYYYMMDDTHHMMSs or in the extended format PT. For example, the first duration shown above would be P the 4th of June 03 T 12 hours 30 minutes and 5 seconds. However, individual date and time values cannot exceed the moduli. Time intervals. A time interval is the intervening time between two time points. The amount of intervening time is expressed by a duration. The two time points are expressed by either a combined date and time representation or just a date representation. There are four ways to express a time interval: start and end, such as the 1st of March 2007 T 13 hours 0 minutes and 0 seconds Z, the 11th of May 2008 T 15 hours 30 minutes and 0 seconds Z. Start and duration, such as the 1st of March 2007 T 13 hours 0 minutes and 0 seconds Z, P1Y2M1 NODT2H3OM. Duration and end, such as P1Y2M1 NODT2H3OM, the 11th of May 2008 T 15 hours 30 minutes and 0 seconds Z. Duration only, such as P1Y2M1 NODT2H3OM, with additional context information. Of these, the first three require two values separated by an interval designator, which is usually a solidus. Section 4.4.2 of the standard notes that, in certain application areas, a double hyphen is used as a separator instead of a solidus. The standard does not define the term double hyphen, but previous versions use notations like 2000-2002. Use of a double hyphen instead of a solidus allows inclusion in computer file names. A solidus is a reserved character and not allowed in a file name in common operating systems. For an LT, start and GT, and LT, end and GT, expressions, if any elements are missing from the end value, they are assumed to be the same as for the start value, including the time zone. This feature of the standard allows for concise representations of time intervals. For example, the date of a 2-hour meeting including the start and finish times could be simply shown as the 14th of December 2007 T 13:30, 15:30, where 15:30 implies the 14th of December 2007 T 15:30, or the beginning and end dates of a monthly billing period as the 15th of February 2008 0314, where 0314 implies the 14th of March 2008. If greater precision is desirable to represent the time interval, then more time elements can be added to the representation. An interval denoted 2007 to 11-13/15 can start at any time on the 13th of November 2007 and end at any time on the 15th of November 2007, whereas the 13th of November 2007 T 9 o'clock 15 T 1700 includes the start and end times. To explicitly include all of the start and end dates, the interval would be represented as the 13th of November 2007 T 000 15 T 2400. Repeating intervals are specified in clause 4.5 recurring time interval. They are formed by adding r to the beginning of an interval expression, where r is used as the letter itself and is replaced by the number of repetitions. Leaving out the value for means an unbounded number of repetitions. If the interval specifies the start, then this is the start of the repeating interval. If the interval specifies the end but not the start, then this is the end of the repeating interval. For example, to repeat the the interval of P1Y2M1ODT2H3OM 5 times starting at the 1st of March 2008 T13 hours 0 minutes and 0 seconds said, use R5. The 1st of March 2008 T13 hours 0 minutes and 0 seconds said, P1Y2M1ODT2H3OM. Truncated representations. ISO 8601-2000 allowed truncation, where leading components of a data time are omitted. Notably, this allowed 2-digit years to be used and the ambiguous formats YYMMDD and YYMMDD. This provision was removed in ISO 8601-2004. Usage. On the Internet, the World Wide Web Consortium uses ISO 8601 in defining a profile of the standard that restricts the supported date and time formats to reduce the chance of error and the complexity of software. RFC 3339 defines a profile of ISO 8601 for use in Internet protocols and standards. It explicitly excludes durations and dates before the Common Era. The more complex formats such as week numbers and ordinal days are not permitted. RFC 3339 deviates from ISO 8601 in allowing a zero time zone offset to be specified as 000, which ISO 8601 forbids. RFC 3339 intends 000 to carry the connotation that it is not stating a preferred time zone, whereas a conforming +000 or any non-zero offset connotes that the offset being used is preferred. This convention regarding 000 is derived from earlier RFCs, such as RFC 2822, which uses it for timestamps in email headers. RFC 2822 made no claim that any part of its timestamp format conforms to ISO 8601, and so was free to use this convention without conflict. ISO 8601 is referenced by several specifications, but the full range of options of ISO 8601 is not always used. For example, the various electronic program guide standards for TV, digital radio, etc. use several forms to describe points in time and durations. The ID3 audio metadata specification also makes use of a subset of ISO 8601. The generalized time makes use of another subset of ISO 8601. The ISO 8601 week date, as of 2006, appeared in its basic form on major brand commercial packaging in the United States. Its appearance depended on the particular packaging, canning, or bottling plant more than any particular brand. The format is particularly useful for quality assurance, so that production errors can be readily traced to work weeks, and products can be correctly targeted for recall. Related standards.